So we're given this problem from college trig. It says a point on the terminal side of theta in standard position is given, and that's this point right here. Find the exact value of each of the 6 trigonometric functions. And I think what happens here is students look at this and they've already started to be ingrained with a unit circle, and they've forgotten kind of where we started from. So here, this point is not on the unit circle. It says it's in standard position, right? It's on the terminal side, so that means we're in this position right here, so it's down here, and we know that this point is not on the unit circle, so we can't use this as cosine and this as sine. Instead, we have to go back to algebra and use Pythagorean theorem. So we know that x squared plus y squared is equal to hypotenuse squared, isn't it? So that's where we are right now. So then I'm going to go ahead and do this math here, and it's going to turn out to be 1/9 plus 1/16. And this is where a lot of people got hung up, because from here, this is where, and this is not my attempt at sarcasm, where our 7th grade math fails us, because they were like, what am I supposed to do with this? Well, what you're supposed to do here is find a common find a common denominator. I didn't go through, when I did this problem, I didn't go through the whole thing about trying to find the least common denominator. I just looked for a denominator, and it turned out to be the least common one. And we know that just as a method, we can always use this denominator as 1 on this side and this denominator as 1 on this side. And what we get is 16 over 144 plus 9 over 144 is equal to h squared. From here, it starts to come together a little bit better, because we get, hopefully you'll start to see this, we have our h squared, our hypotenuse squared, is equal to 25 over 144. And hopefully what happens is you recognize that this is a perfect square and 144 is a perfect square, and hopefully the light comes on and you're like, okay, this is getting better. But a lot of people didn't get to that, so here we go. So I'm going to take the square root of both sides. The square root of h squared, of course, is just h. And we know that if we take the square root of a over b, by rule, it's the same as the square root of a over the square root of b. Over b. Why is that true? Because radicals are rational exponents, and we know that exponents are distributable over division. So that works out. So our answer here is 5/12. From here, we can start putting all of our pieces together. And what I did here was I wrote down some stuff that I know, and I know from geometry that sine is equal to opposite over hypotenuse, that cosine is equal to adjacent over hypotenuse, and somebody out there is saying SOHCAHTOA, it's actually true. Tan is equal to opposite over adjacent. And I'm just going to fill in the blanks there. So as we kept going, I started to take sine, and sine is opposite over hypotenuse. I labeled the fact that the x value is the adjacent side and the opposite is the y side. So I'm just going to take sine, and sine of this is 12 over 4 is 3. So sine is equal to 3/5. And I'm going to do that for all of them. Just going to just go all the way through. I'm not going to actually do all the work because I think you know how to figure these out. But cosine was equal to 5/13. Tan, which is opposite over hypotenuse, right, was equal to, I'm sorry, opposite over adjacent. So we have opposite over adjacent is equal to 3/4, isn't it? So we get 3/4 here, right? Oh, man, I messed that up. Cosine here is 4/5. I was looking, I was like, what the heck is wrong here? So cosine, from here, look, I'm just going to take the reciprocals here. This is, cosecant is the reciprocal, so that makes this 5/3, doesn't it? The reciprocal of this is secant, and secant is 5/4. And all I'm doing is taking the reciprocal values here, and cotan is obviously equal to 4/3, isn't it? So that's how I did this problem. I hope we can agree that the toughest part here was recognizing what we had and didn't have. We're not on the unit circle, so we had to use a different technique. And the technique that we used was Pythagorean theorem, where we took x squared plus y squared is equal to r squared or h squared or c squared, however you want to do that. So look, I hope this is really helpful. Vaya con Dios.